Okay, so just to reconfirm, you can see my screen, right?
Yes, sir.
Yeah. So this is week number 7, which means we are officially into the second half of the course. So last time we had started with some methods for ODE solving, right? And the basic idea was xn plus 1 was xn plus delta t times something, right? Let me make it bigger. Yeah, okay. And this something determines the scheme that we are using. Okay, so for forward Euler, this would have been f at xn tn, right? Now, if it was backward, then it would be f of xn plus 1 tn, right? And then there was another method which was trapezoidal trap, which was like f of xn tn, which is this Euler, and plus f of xn plus 1 t. This was n plus 1. Okay. N plus 1 divided by 2. So it's an average of both of these. Okay. Again, so this is explicit, right? Explicit. This is implicit. Why? Because xn plus 1 is in terms of xn plus 1. So there is some equation which has to be consistent. So it has to be solved such that xn plus 1 makes some sense. Okay. And this one has both explicit and implicit terms. So it's semi implicit. So these were our first order terms, right? First order method. Then we looked at higher order methods. Higher order. So first was predictor, then corrector method. Okay. So what's the idea? So the first step is Euler forward. So xn plus 1 is xn plus delta t times f of xn tn, right? So this is standard Euler method. And then you say, okay, this is not actually my xn plus 1, but I am going to use this for evaluating xn plus 1. So the second step, so this is the predictor, right? And then the corrector step is that actual xn plus 1 is xn plus delta t times f of xn tn, same as before, and f evaluated at this xn plus 1 which we predicted, right? So first we say that that is xn plus 1, then we say no, 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 that is not xn plus 1, but I'll use it to get the correct xn plus 1. Okay, so this is t and n plus 1 by 2 because we are taking average of both this. Okay, so this is just like okay, so this should be triple star. So if this was not a star, then it would be just a trapezoidal, right? So difference, this is different from trap, because in trap you just use xn plus 1. Okay, so and then the second method was Rangekutta. Okay, Rangekutta 2, which means second order, which was again, first you say that xn plus 1 is xn plus delta t times f of xn plus half and t n plus half. This is, I think, star, right? And how do you get this xn plus half star? Well, that is just xn plus half star, which is xn plus delta t f of xn tn by 2. So it is similar to this predictor corrector, but rather than going one whole step in delta t, you just go half step in delta t. Okay, and whatever value you get, you use that xn plus half star to predict your next step. So now you don't use trapezoidal here. Okay, so this is your RK2. So this quantity is sometimes called K1. Okay, and then comes the hero of all the ODE solvers, well, for most of people, which is RK4. Very standard thing. Okay, and in that case, you define not just K1 but K2, K3, and K4. K1 is just delta T f xn plus xn and tn. Then K2 is given in terms of K1. So it is f of xn plus half tn plus half star, right? And this is determined using the same rule. Xn plus half star is xn plus K1 by 2. So that's how K1 enters into K2. Similarly, K3 is delta T times f of xn plus half, some other approximation of n plus half, and t n plus half. Okay, and how do you get this approximation? Again, same thing. It's going to be xn plus k2 by 2. Okay, so we are trying out different combinations. In K4 is going to be delta T f of xn plus 1. So this will be one full thing. Okay, triple star and T n plus 1. And again, formula for triple star inverse K3. So it is going to be xn plus K3, not divided by 2, because we are taking one whole step, right? It is n plus 1. And then you say that the ideal combination that should be used, that's something, right? It's delta t times something. It is a linear combination of k1, k2, k3, and k4, some kind of weighted average, where k1 and k4 get half the weightage of k2 and k3. So these are 2, 2, these are 1 and 1, and then you take the average, so total is 6. Okay, so the best combination is this one, and if you calculate the error, it will be order of delta t to the power 5. Okay, it's fourth order method, which means error will be of the order of 5, which is very small, right? Let's say if delta t is 0.01, which is not very small, and your error would be order of 10 to the power minus 10, correct? Which is very small. That's why it's famous. Nowadays, when we use computers, generally people use something called ODE 45, Okay, this is in MATLAB. Sorry, I don't know if it's in Python as well, but in Python there is something called solve IVP. Maybe we are going to learn this, and by default they use some RK4 5, so some combination of fourth and fifth order method, which is even more accurate. Okay, probably in future we'll do some examples using this, and this has become now the standard. All right, then the next thing that we looked at was multi-step methods. uh, Multi-step, and the idea is that to predict what happens at n plus 1, you don't just look at Tn, but you also look at Tn minus 1 and possibly Tn minus 2, etc. So the past is something you take into account. Okay, it's like a Markov chain, if you know what I mean. So, all the methods that we have seen so far don't follow this, right? So it's a single step. So for this, one example is leapfrog. Okay, that if you are at x and tn, okay, we are writing like this, right? And you want to jump to xn plus 1, tn plus 1, then normally what you do is add something to this point, right? But in leapfrog, you add to this point, xn minus 1, tn minus 1. So your xn plus 1 is xn minus 1 plus something. So now the step is 2 delta t, right? This is 2 delta t. So 2 delta t, and what you use here is this midpoint, which is xn. Okay, so it's like frog is jumping from here to here. There are some leaves here. All right, and that's how it works. So now once you are here, you use this xn to predict xn plus 2, but the slope is calculated at xn plus 1, right? Like that. One good thing is that you can write this as xn minus 1. I can take this to the left hand side, right? So xn plus 1 minus 2 delta t f of xn tn, which means it is time reversal symmetric, right? So if you are at xn plus 1, if you want to go back in time, you do exactly the same thing, right? Xn plus 1, but plus ka minus because you are going back in time. So delta t becomes negative delta t, but the equation remains exactly same, which is why this is good for solving problems which has time reversal symmetry. Okay. By the way, if you don't know what time reversal symmetry, it's very easy thing. Let's say you are taking a video of something, a pendulum that is in vacuum, and it is swinging, right, back and forth, back and forth. So this is your video one, and there is another one which is video two, which is reversed in time. Okay, so it starts from here and then swings back and forth. And then you ask two people to watch both of these videos, and if one looks okay and the other also looks okay, that means it's time reversal symmetry. If one is okay but other looks funny, odd, then it's not time reversal symmetry, right? For example, if there is some drag, right? So this guy will see that the pendulum is swinging, then slowly after some time it comes to rest. What will happen here? Well, it starts from rest and it starts swinging. Okay, so it looks something like odd. And even better example is if someone is drinking something, let's say tea or coffee, and they spill the coffee, then it's very easy to see which one is in the correct arrow of time and which one has the wrong arrow of time, right? In the other case, the spilled coffee would come together into a cup and it will look odd. So this is time reversal symmetry without mathematics. In mathematics, you say that t should go to minus t and velocity should go to minus u. Okay, and then your solution x of t should go to x of minus t. Okay, so this is what time reversal symmetry means. If you have any questions, you can ask. Okay. Yeah, there was professor mentioned about parabolic throw, right? So it is very symmetric if you ignore friction, if you start at angle theta with some speed v, it will come with the same speed and same angle theta, right? Here it will be theta and v speed v. So if you play the video in reverse in time, it starts with some velocity v in the same angle theta and it comes back here with the same velocity v. So that is time reversal symmetry. Now if there is some friction, and we have all seen one example of this, right? It's javelin. It looks something like this. So if you look at the throw, it starts off as very linear and then it curves. Okay, and of course one reason is drag, but there are also many other reasons why it is not parabolic, right? Because center of gravity is different and there is some point of action, etc. There is a lot of physics going on. Yeah, but when Neeraj Chopra or Arshad Nadeem throws in this direction, it's very different than if we just play it back. Okay, so I hope that is clear. And there is a general class of algorithms, right? Which is called, what was the name? Adam. Yeah, Adam Bashforth. And the general form is xn plus delta t times something, right? Now they say that it's something can depend on all of the past. So xn, then n minus 1, n minus 2, etc. So it could be n minus m and t n minus m, right? And this m could be starting from 0. So 0 means you start at xn and it can go up to k points in the past. So this is number of points in past, right? Rather k minus 1 because we are starting from 0. Okay. And depending on and yeah, there are coefficients, very important, b, k, m. Okay, so if k is equal to 1, it means it's just Euler forward, right? So actually k minus 1 is the number of points in past because 0 is just the same point, but if it is 2, then you are looking at 1 point in the past, right? So k is equal to 2, then betas are tabulated, they are not, right? So for k is equal to 2, we can write explicitly 3 by 2 times f at that value and minus half times f at value in the past. Okay, and more you have k, better your approximation will be. And that's how these betas are determined, right? To get the best matching with the function. So you match it with the Taylor expansion and see how far you can go. Okay, and then we looked at Fourier. Yeah, before that, if you have multiple equations, so we are dealing with x dot is equal to fx, right? Now this could be one equation, x1 is equal to fx1, and x2 dot could be some fx2, but this f need not be same as this, right? So we call this f1, this is f2, right? x3 dot 3, x3. So if you have this kind of set of equations, it's very easy to solve. Why? Because they are all independent, right? I can just solve this, then this, then this. But in general, they are coupled. So it won't be like this, but in principle, this could be a function of x1, x2, x3. This could be function of x2, x1, x2, x3, etc. Right? So general way to write this is that you have some vector x dot, and there is a vector of function. So this is f1, f2, f3, etc., which operates on this vector x. Okay, and this again can be solved using any known method. For example, Euler forward xn plus 1 vector, which means all the components is going to be xn plus delta t times f of xn and tn if there is. Okay, so that was that. Then there were some examples. One is x double dot is equal to minus x, right? So this is an example of this. Why? Because you have to break it down into single order equations. So since this is second order, we have two equations of first order. So the first one is just a definition, x dot is v, and then we define v dot is equal to minus x. So this is your spring mass, oscillation, pendulum, anything, right? And if you look at phase portrait, x versus v or p, it will be a circle rather an ellipse. Okay, and how do you know this is a circle or ellipse? Well, you can multiply this by x and multiply this by v. So this is just a trick. If you are doing physics, then these tricks are important. So x dot becomes vx and v dot becomes minus xv. Then add them up, you get x dot plus v dot is equal to 0, which means derivative of x square plus v square divided by 2 is equal to 0, which means x square plus v square is some constant, which is an equation of circle. Okay, so this is important to remember. Derivative of x square will be 2x into derivative of x, which is x dot. Okay, so this is the trick. Anyways, and the second example was x double dot was x minus x cube in this case. So the for this energy was this one, right? This energy was x square plus v square rather by 2. Similarly, if you just say this is some u dash of x, right? So this is force, so minus u dash of x. Then u of x will be integral of this, the potential, which will be x to the power 4 divided by 4, I guess, yeah, and minus x square by 2, right? How do we get? So minus integral of fx dx. Okay, so if we plot this energy potential energy function for small values of x to the power 4 is very small. So this term dominates the second term, which is minus x square by 2. So it will be like a small parabola here, negative parabola, right? For large x, this term dominates. So you should get something like this. Okay, and then you patch them. So you get something like this, which is also called a W potential, right? And now you can immediately see that your particle can stay here was here. These two are stable equilibrium and there is one unstable equilibrium here. So if you start your trajectory somewhere from here, it will oscillate like this, right? From here, it will oscillate like this. Same thing happens here. But if you start from here, it will go from here to here, all the way here, then come back, right? So now if you think of a perpendicular direction, which is your V, then you know that oscillations are circles, right? So now you can make this plot x versus V. So there are equilibrium points here, and around them you have these circles, as they are called center. Okay, but if you have large initial condition, then it does something like this. So that's how you get phase space trajectories. And this was a Duffing oscillator. Okay, now let's talk a little bit about Fourier transforms. Fourier. Okay, and what is the idea? Idea is that all sines or cosines are orthonormal. What do I mean by that? If you take integral of sine of some, say, 5x and sine of 2024x, I don't care. As long as these two are different, which means so you take from 0 to 2 pi. Okay, because 2 pi is the period. You get 0. And if they are equal, then you get some non-zero number. I think it's 2 pi or something. But basically, sine k1x and sine k2x dx dx is some delta of k1 k2. Okay, so only when k1 is equal to k2, you get a finite number. If it is if they are different, then you get 0. Okay, so which means in some abstract space, again we had discussed this, right? This sine x, sine 2x, all of these are some perpendicular functions, right? Sine 3x, etc. Which means any function. So any function fx which has period L, okay, and finite discontinuities, can be written as sum of these signs. So now f can be complex also. So instead of sine, we use e to the power ix, e to the power I 2ix, etc. Okay, e to the power 3ix, and also minus ix, minus 2x, right? So fx will be sum over all not sine, e to the power I k n x, right? Where n is from minus infinity to infinity, and this of course does not depend on f yet. So there will be coefficient of this terms, right? Which determines which frequency is present in what amount, right? So let me just confirm. Yeah. Okay. And this kn will be 2n pi by L. Why? Because if you replace x by x plus L, then this 2 pi by L, LL will be cancelled and you will get 2n pi. So, and e to the power 2 in pi will be 1. Okay. So, all these functions are periodic with period 2 pi. So, your entire function f of x will also be periodic with period 2 pi. Okay. And then you can go in the reverse manner, which is what you generally do. You want to calculate fn hat, then you say it is 1 over 2 pi or L. L is the length of the period fx e to the power minus I k n x. Okay, and dx. So there is one funny thing that people often miss, and it's actually interesting. Fx is some infinite continuous function, right? That is defined from minus infinity to infinity, something like this. It is periodic, but nonetheless it's continuous, right? It has infinitely many points, and these points are uncountably infinite, right? Very continuous. On the other hand, your fn are discrete. You have 0, f0, which has some value, right? Some real and imaginary value. Then at 1, you have f1, right? So you have only discrete values, but the information that is contained in fx is contained in this fn hat also, which is very interesting, and it's paradoxical, at least superficially. But the resolution is that since fx is periodic, and since we have this finite discontinuities, and also the derivative has to be bounded, and there are some conditions, so they ensure that all the information that is contained in fx can be contained in this discrete fn's. Okay, so it's interesting. And as you take this period L to infinity, you go to real Fourier transforms. Okay, so ideally this should be called Fourier series, not Fourier transform, but that's alright. In physics, we mostly work with Fourier series. Okay, especially in condensed matter. Some of you are working. You work with lattice, which is repeated after some period, right? So when you are doing simulations, you have periodic boundary conditions, or what some people do. I'm not an expert, but they define something called supercell. So in which the periodic boundary condition is on some supercell, which could be 2 cross 2, etc. Okay, but nonetheless, you do your simulations on some finite system. That's the only thing you can do, and then you imagine that it is being repeated everywhere. Okay. Anything else? Yeah, discrete Fourier transform, very important. So, of course, computers can only handle discrete data, right? So you have discrete Fourier transform. So earlier we had fn cap is equal to 1 by L integral 0 to L fx e to the power minus I can x. Now you said that, okay, from 0 to L you have n points. So this is your 0, then 1, which is dx, then 2 dx is 2, etc. And the second last point will be n minus 1, because we already know the value at L. So we end here. So in total we have n points, right? So now we have fj, right? Fj is just f at j dx, correct? If f0, then it is at f of 0. F3 is at f of 3 dx, etc. and then we can write Fn cap is equal to 1 by L. This integral becomes summation. So summation will be from 0 to n, rather n minus 1. Okay, and this Fj e to the power minus I, kn was 2 pi n divided by L, and this x becomes L by n times j, right? This L by n is the dx, and then there was this dx which I always forget. Dx is L by n, which can be taken out. So this boils down to 1 by n, 0 to n minus 1, sum over all j, right? Fj e to the power minus I 2 pi nj divided by n. So now this is the discrete Fourier transform which the computer can easily calculate. Now why it is easy? Because some very smart people developed something called fast Fourier transform. Okay, and it takes into account that when these terms are even, you can split, you can take some factors out, then again do the same thing. So you have this divide and conquer strategy. There is a very nice video for this. Okay, if anyone wants to see, I'll just share the link later. But it's very beautiful. Okay, so with that, we'll end. And any questions in this theory part? If not, then one thing, yeah, Nyquist. It might be new for some people, and there is a nice idea in which you can explain. It's that suppose you have rotating wheel with some frequency f, right? So time period is 1 by f. Let's say f is uh, 10 hertz, then this time period will be 1 by 10 seconds, so 0.1 second. So it will repeat after every zero point 0.1 seconds, and you want to find the frequency of this. So what you can do is put a dot here and let it evolve in time. So after some time, this dot will be shifted to here, right? Then it will be here, then it will be here, etc. Right? Here, and then finally it will come back to its initial position. So if this time is delta t, then you can calculate that the time period is roughly n delta t, and from that you can get this frequency. Now suppose your delta t is high. If oops, just give me a second. If delta t is half this time period or higher, then what will happen? You start from here. In the next observation that you will make, the dot would have moved more than half the circle. So you will see somewhere like here. Then more than half the circle, somewhere like here. So what you see is that this initially it was here at T1, then at T2 it became here, then T3 here. So you see the dot going in the opposite direction, right? Which means you can't really predict the frequency of this thing. So this criterion, which means that delta t should be less than half the time period, and this means that frequency of measuring, okay, should be less than, sorry, greater than twice the frequency of actual moving object. And this is the statement of Nyquist theorem. The way professor has written it, it is h is equal to lambda mean by 2. So lambda mean is like time period. Okay. And h is like our delta t. So we have to have, if lambda mean is something, then the h that we need to take has to be at least lambda mean by 2. Okay. That's the statement. And then there was one important remark at the end, which was that if you want to have a very good result with derivatives, you can do forward difference or using the spectral method, but this ratio is 1 over 6, which means at least for calculating derivatives of exponentials, h spectral needs much less h. Okay, sorry, much higher h means you can work with higher delta x. So this delta x is same as h. Okay. So you don't want delta x to be very small, right? Because it will take longer. So using spectral method, you can take higher value of delta x or h and get the same result. Okay. Now let's look at some problems. Most of them are very easy. So the first one is, what is the stability condition for the differential equation with negative alpha using trapezoid method? X dot is equal to alpha x. There should be x here. Okay. So we know the trapezoidal method is xn plus 1 is equal to xn plus delta t times f of xn tn. But if we write just this, then it becomes Euler. We have other term xn plus 1 tn plus 1 and take average. So it's plus divided by 2. So in this case, xn plus 1. I think we have done this last time also, but let's do it again. And f is just alpha times x. So this is alpha xn plus alpha xn plus 1 divided by 2. So xn plus 1 will be 1, and I take this term to the left hand side. So 1 minus alpha by 2, alpha delta t by 2 is equal to xn 1 plus this term, right? So alpha delta t divided by 2, which means xn plus 1 is some number times xn. This number is 1 plus alpha delta t by 2 divided by 1 minus alpha by 2 delta t. And this we can say it is lambda times xn. And the condition is that mod lambda should be less than 1, right? Only then it will stabilize, which means mod of 1 plus alpha delta t by 2 divided by 1 minus alpha delta t by 2 should be less than 1. So the correct option is first one. Second one, to solve differential equation with time reversal symmetry, which of the following schemes is applicable? Yeah, perhaps you can write the answer in chat box. Yeah, 1 1 1 1 leapfrog. Very nice. Yeah. Okay. So as we saw, it's leapfrog, not Euler, not trapezoid, not RK4. Why? Because all of them look forward, right? Euler just looks at this point. This is Euler. RK2, RK4 look at these points also, somewhere in between. Trapezoidal looks at this and this, both of them, etc. Sorry, Euler looks at this point. So all of them are looking forward, except the leapfrog, which if the guy is here, then he looks at this point, yeah, and the rightwards point. And both of them get equal contribution, right? It's half half. So 1 1. That's why it's going to be type symmetric. Okay. And the third one is uh, write a Python code. This we'll do later. So there are 3 questions with Python codes, which we'll do. But let's finish with this ones, theoretical. What are the time scales of the following differential equations? Type in the chat box, please. Question number 6. Answer. Anyone? This was done in the course. So we have dx by dt is equal to x square minus 10 raised to 6 x. So if you compare this two, you get x over t, yeah, is equal to x square dimension. So 1x gets cancelled and you get t is equal to 1 over x. Okay, so the first time scale is 1 over x. Second one is when you compare the other two, this two. Now your x divided by t, I am dropping the dimension size, is 10 raised to 6. Okay, so this x get cancelled. 1 over t is 10 raised to 6, which means t is 10 raised to minus 6. Okay, so the correct answer is, oh, I think it was supposed to be this one, 1 over x 10 raised to minus 6. Okay, yeah, some of you wrote actually. So, okay, Dipankar extrapolated, used some Lagrangian polynomial and derived it must be the fourth option. Anyways, you got the logic, right? So you compare the terms and get the time scales. What does this mean, by the way? We are doing like machines, but it means that there is one time scale. If let's say it's in seconds, then it means that up to this time scales, this term dominates, right? Because x is very small. Let's say we are starting from 0, so a very small number. Then x square will be very small, but this term will be very large, right? Let's say x is I don't like x is 1, then x square is 1, but this other term 10 raised to 6 into x will be 10 raised to 6. So it's almost like you can neglect this. This can go on up to this many seconds. Okay. After that, your x might reach to some level where this term dominates, or that also becomes important. Okay, so that's the idea. In fact, you can try to plot this function. What will be its plot? So for small x, as we saw, it's like a very steep negative function, negative slope function, right? For large x, you see this behavior. And you can compare these two time scales also, yeah, where both the effects come into play. So 1 by x is equal to 10 raised to minus 6, which means x is equal to 10 raised to 6, which means about this time scale, both these terms will have equal importance, and since the sign is negative, it means your x dot will be close to 0. In this case, it will be exactly equal to 0. Yeah, because we haven't ignored any coefficient or anything. So after x is equal to million meters, both the terms become important. Okay. And what you should do as in homework in a tutorial session is make it non-dimensionalized. Then you will see it's a very nice equation. You already know the time scale, right? And the length scale. So you can do it. And so what you should find out is that this ugly 10 raised to 6, which no computer scientist likes, right? That will just disappear. Okay. Yeah. So sorry, I got disconnected. Okay. Question number 7. Which of the following method is most accurate? Is it Euler, RK2, RK4, or leapfrog? 3. Aparna says 3. Anil Kumar 3. Dipankar 3. Rajesh 3. Right. Okay. So that's the correct answer. Why? Because this is first order, this is second order, this is fourth order, and leapfrog is also first order, or at max it's second order, right? And error is delta t raised to order, right? Sorry, order plus 1. So if it is first order, then the error will be order of delta t square. So the highest order method is Runge-Kutta fourth order, which will have error of delta t power 5. Okay. And what's the Fourier transform of the function? Should say rather Fourier series coefficients, but that's all right. We are doing physics. Of this function, f of x is equal to sine of 2x. So as I talked, what this means is that what Fourier transform in general means is that any function that is periodic like this can be broken down into sines of different frequencies, right? So it could be something like this, and there is high frequency, so like this, and the amplitude of these waves are your Fn, right? And this could be say k is equal to 1, this could be k is equal to 2. We writing, oh, we are calling it n. Okay, so n is equal to 1, n is equal to 3. So this is like sine 3x, etc. Okay. In actuality, we are using exponential function. So sine is just one component of it, the imaginary component. So this is e to the power 2 ikx, etc. So the idea of f of x, the Fourier transform itself is to decompose it into different frequencies. But look what we are given. It's already one single frequency, right? Some single mode. So we really should not try to use that formula, although we can, you absolutely can. But the better way is to just write sine 2x in terms of this e to the power ikx. Do we know how to write sine 2x? Yes. So formula for sine theta is e to the power I theta minus e to the power minus I theta divided by 2i. And what's the proof? Well, you use just the Euler identity, right? Cosine theta plus I sine theta. So now sine 2x will be e to the power 2ix minus e to the power minus 2ix divided by 2i. So let me write it like this separately, 1 by 2i times e to the power 2ix and plus minus 1 by 2i times e to the power minus 2ix. Okay, so this is going to be your second mode, right? So f2. Why? Because there is 2 here. Similarly, this is minus 2. So this is going to be your f of minus 2. So what it means is that f2 is 1 by 2i. F minus 2 is something minus 1 by 2i. F other is 0, right? Because there is no e to the power 5ix term, right? If there was, then f5 would be non-zero. But there are no such terms. There are only two terms, which means we can write in shortened notation fn is some delta n comma 2. So when n is equal to 2, it will be 1 by 2i, and plus when n is equal to minus 2, it is 1 by minus 2i. So which one is the correct answer? 4. Will it be 4? 2. Yes. Yeah, 2. Correct. Okay, because there is minus here, minus 2i. And it has to be minus 2i. Why? Because look at this. F is real. What that means is that F2 has to be complex conjugate of F2 star. So if one is 1 by 2i, then the other will be minus 1 by 2i. By the way, you can write this as minus I by 2, and this will be plus I by 2. Okay, so I becomes minus I. Okay, perfect. Again, very easy, similar question. fx is 4 cosine x plus 2 sine 2x. Again, it's already given as a sum of these frequencies. So all we have to do is just make them exponential. So 4, what is the formula for cosine x? E to the power ix plus e to the power minus x ix divided by 2, and plus 2 times, well, it is sine of 2x, so all the modes will be 2. Nonetheless, let's just write e to the power 2ix minus e to the power minus 2ix divided by 2I. So this is 2 times e to the power ix or I1x plus 2 times e to the power minus I1x, then 1 by I times e to the power 2ix and minus 1 by I e to the power minus 2ix. Okay, so now we are asked k is equal to 1. So they were calling n earlier, now they are calling it k, but that's alright. So we have to look at k is equal to 1. So this is our k, right? E to the power ikx. So what's the coefficient of this? It's 2. So the answer will be 2. Okay. And once you are familiar with this, you can just look at it. Because you are asked at Fourier mod 1. So this is frequency 2. Does not matter. This is frequency 1. But it will be sum of 1 and minus 1. E to the power ix and minus x. So just half will be the mode 1, right? So it will be half of 4, which is 2. Okay. Last one. Yeah, many of you answered. Okay, so last one is again same thing. So it's the same thing in 2 dimension. If you have 2 dimension, then your Fourier coefficient will have two terms, right? Kx and ky, two indices, and the function will be ikx x and iky y. Okay, so we have to transform this one into something that looks like this, and that is again very easy. 4 times what is cosine x? E to the power ix plus e to the power minus ix divided by 2, and sine y. So e to the power iy minus e to the power minus iy divided by 2I. Okay, so all in all you get 1 by I. This two twos are 4, which gets cancelled, and then you have e to the power ix, e to the power iy, then something with e to the power ix, e to the power minus iy, right? Then you have minus ix and plus iy, and the last will be minus ix minus iy. But we are asked at 1 1, which means this one, plus 1 plus 1. So what's the amplitude? That is going to be 1 by I. So what is the correct answer? 4.
minus I.
Yes, minus. Yes, Dipankar, 4. 1 by I is minus I. Okay. If you were asked 1 comma minus 1, then it will be this coefficient divided by I. This will be minus 1 comma 1. This would be minus 1 minus 1. And all the other coefficients, all the other amplitudes are 0. Okay. So 2 comma 3 will be 0. Okay. So any questions in this section? Then let's do coding. Yeah. So we have three questions. The first of them is write a Python code to solve this equation dx by dt is equal to t minus x by 2, and the method is RK2. Okay, delta t is given, initial is given, write the final answer. So the syntax remains same, right, in all the questions. So let's do. Just give me a moment. Yeah, so let's start. First, let's define the function. Let me call it f1 of x. So f1 of x comma
Sir,
t.
please zoom it now.
Oh
I
yeah,
can't see it.
yeah. Thank you for remembering. Better now?
Yes.
Yeah. And the definition of f1 is this: t minus x by 2. Now let's define the method RK2. It already gives everything. So first argument should be the function, and then we need to know the initial position, initial time, dt, and the final time, which we'll call t end. So as we did earlier, we take a while loop, right? While, and then there is some t. It should be before t end. So we run till t end. So we start t to be t0, the initial point, and x is x0, and then we'll update according to RK2. So while there should be double dot. And what was the definition of RK2? First you get K1 and K2, right? So K1 is just your Euler forward dt times f of x comma t, and then K2 is average of two things, f of x plus K1 by t. What this is like your character predictor, and t plus dt by 2. Okay, and then x is x plus K2. So first you find dt times f, the Euler step, and use that K1 to find the actual step, which is RK2 step. And then x is x plus K2, and t is t plus dt. And you keep on doing this till t becomes greater than t. So after that, we return t, sorry, x, right? This will be the x after the iterations, all the iterations. And now let's write the initial condition. T0 was 0, x0 was 1, dt was it 0.01 or 0.001? Yeah, 0.0001. So dt is 0.01, t end is 1, and then we run RK2, and we call this x, right? Let's call it x final, and then we have to print x final but we have to round it to 2 decimal points. X final, comma 2. Okay, let's run this. What happened? Oh, return should be inside the function. Okay, it gives 0.82. Alright. Which is the correct answer, I think, and we can check. So we'll do the checking later. So turns out this is solvable. So we'll solve this and see if it is okay. Okay, the next question, dx by dt is minus cos x times cos of t, and use RK4 with similar delta t and initial is half, and find that t is equal to 1. Should I copy paste this or should I learn from the previous assignment? Oh yeah, so last time we had some issue in one of the questions, right? This one, which was question number 5. Turns out I was missing this star sign. So I was doing the multiplication without this sign. That's why we had some error. After removing it, we get the correct answer 19.83, and in fact you can solve it analytically. This is the expression, and you see that both the curves are matching. Okay, so I think I have uploaded the correct one. If not, then correct by yourself. There should be a star here. Okay, okay, let's write this one. So again, define a function f2 of x comma t. And what should be this one? Anyone? What should I write here?
minus of x cos t.
Yes, it should be minus
minus
this.
x cos t.
Okay, yes. Because this is a function of dx dt, right? Whatever dx dt is, you write. So in exam, make sure you don't do this kind of silly mistakes. Okay, even though it's plus, you have to take it to the other side. Now let's define RK4 routine. Again, it's a function of the function x0, t0, dt, and tn. Yes, t is t0, x is x0, and while t is less than tn. Now we have to define k4, right? k1, k2, k3, k4, and it already gives. So k1 is dt times f of x comma t. That is correct. K2 is dt times f of x plus k1 by 2 and t plus dt by 2. That's true. And k3 is same thing with k1 replaced by k2. So it's the same thing. K4 is same as first step but with x being x plus k3, and t is t plus dt. And the x is this linear combination of k1, k2, k3, k4 with 1, 2, 2, 1 coefficients. Okay, so this looks correct. And then we return x. Oh, we have to update the time also. And in this case, it actually matters whether we update or not because it's not autonomous, right? There is cosine of t term.
So K1 should be dt to F2 of F2xt, right? To
Yeah,
find the
so it should
function
be
F2.
f2, but the argument here is f. So this is a
Okay.
definition of RK4. So if I write F2 here, then it should be F2 everywhere. Here I'm writing just F. Now T0 is 0. Yes. X0 is half. Dt is 0.01. T end is 1. X final is RK4. Here I have to mention the function. And the name of the function is F2. So here I write F2. Then X0, T0, dt and T end. And again print the final answer. And it gives 0.22, which is correct. Yeah. What we'll do after this, let's do this. Again, it's very similar. So now the equation is dx by dt is equal to x plus e to the power t. And the scheme we have to use is predictor corrector. In data t, everything is given. The same syntax. So let's define f3 of x comma t, which is x plus np dot exponential of t. Now define predictor pc, yeah, f comma again x0 t0 dt and tn. T is equal to t0, x is equal to x0, the loop, and then we have two steps, right? So k1 is this thing. So better way to write is first you predict x. So you say x predict is x plus dt times f of xt. So this is predictor, right? Which is just Euler. And the next step, so this that was the k1 part. Next part is
So
actually
could
x.
you please enlarge that? Could you please
Okay,
enlarge
yeah,
X3?
better.
Okay, sir. Okay.
Yeah. So the first step was predict. So we predicted x according to Euler rule, and now we correct ourselves. We say that x is going to be x plus dt times something. Yeah, just as usual, and that something is going to be combination of x comma t at x and then at what we predicted using Euler, t plus dt, and by 2 because we have 2f evaluated. So it's the average of Euler and what is predicted by the Euler. Okay, so this is the step for corrector, and this is trapezoidal rule, right? It's like trapezoidal, but this is not xn plus 1, rather it is the value of xn plus 1 as predicted by Euler. Okay, and then x is updated, t should be t plus dt. And then we return x, and it's the same thing, right? X0 is 0, x0 is 1, sorry, t0 is 0, x0 is 1, delta t is 0.01, and final is 2. So t0 is 0, x0 was 1, dt is 0.01, and t end is 2. And then we run our machine. X final is equal to PC of F3 at x0 t0 dt t end, and then print the value rounded up to 2 decimal points. And it gives 22.70, which is correct. Okay, so any questions in this section? Okay, so basically we are done. Now the last point that I want to do is, if you want to verify, if you are not very confident, like I am not very confident, then I would try to solve it and see if the solution matches. So let's do that quickly. These are slightly complicated equations than the previous assignment, but I realized they are still doable. So this is t minus x by 2. So how do you solve them? First is take the x terms to the left half. It becomes x by 2, right, is equal to t by 2. So on right hand side we have just t. On left hand side we have both dx by dt and something which is linear in x. So now you have to think about this, that if you have exponential of t and then take derivative x times exponential of t and take derivative, then you get dx dt times exponential of t plus x times exponential of t. So if you take out exponential of t common, you get something like this, and this is the form we have, right? Except this factor of 2. So for this factor of 2, we should have factor of 2 here, so that now this becomes e to the power t by 2, and then when you differentiate this exponential, you have a factor of 2 here. Okay, and now this is exit, which means we can write this as d by dt of x times exponential of t by 2, and outside we have exponential of minus t is equal to t by 2. So now d by dt of x e to the power t by 2 is equal to t by 2 exponential of t. Okay, and now you know how to integrate this, right? So this is integral of d x e to the power t
That e
by
to
2.
the power should be t by 2, right?
Oh
I
yeah,
can
t
see.
by 2. Correct. Thank you. So this will be t by 2. And this will also be t by 2 e to the power t by 2. T is from 0 to t, and this is t is equal to 0 and x is equal to 1, right? Initially it is 1, and then t comma x. This you can solve, right? This is integrate by parts, and I'll just write down the solution. But now this is doable, right? So this turns out to be x of t is equal to 3 times exponential of minus t by 2 plus t minus 2. Okay, and we wanted x of 1, so it will be 3 e to the power minus half minus 1. Okay, so you can check this. Similarly for this one, this is easier because you can separate the variables, right? So dx by x is minus cos t dt. So now just integrate from, so x is from half, right? It starts from half to x, and let's call this x0, and this is from 0 to t. So this is just ln of mod x divided by x0 is equal to, what is integral of cosine? It's sine. So it will become sine of t from 0 to t, but sine of 0 is 0. This is just minus sine of t. So x will be x0 e to the power minus sine t. And we were asked x of 1. So this will be 0.5. Yeah, x of 0 was 0.5. So 0.5 times e to the power minus sine 1, whatever it is. And this is actually 0.22. So this is the correct one. In this case, it was, I think, 0.82, right? Let me check once. Yeah, 0.82. And what we should do, I will do just for one case, is plot this function and see if it matches with the solution, the entire solution. Okay. And this last one, which is similar to the first one, right? So now in front of x we have minus. So what it should be? It should be d by dt of x times e to the power minus t. And this will be exactly this one with exponential t sitting here, which will nicely cancel with this one. So we just get x e to the power minus t is equal to, so d is equal to dt. So integrate this from x0 0 to x comma t. This is from 0 to t, which is just t, right? So this is x e to the power minus t minus x0 is 1. So this will become 1 is equal to t. So you get x e to the power minus t as 1 plus t, and take this exponential to the other side. So it is 1 plus t times exponential of t. Okay. So let's just, to end it, let's plot in one of the cases. Let's do it in the last case. So to plot it, I need to store all the x's. So I say x values. This is what we had done last time too, right? We start with x and we'll append. T value will be t, and after updating, we append, right? So x values dot append x, t values dot append t, and then we need to access them, so we return those values as well. X values, comma, t values, and then we need to access all these three. So we say x final, which is the final value of x, right? The way we have defined, and then let's call x values as x, so the entire vector, and t values as t. Then we can plot here t dot plot t comma x. So we need to label, sure, why not? Okay, so we see this kind of exponential thing. And now let's compare it with the real solution. What was that? So I'll say plt dot plot, and the solution that we got was 1 plus t, so t times 1 plus t times np dot exponential of t. Yeah, and if I run this, it won't run. Why? Because I am doing exponential of a vector, exponential of a list, which is not allowed. I have to say t is equal to np dot array of t values, of t rather. So this should come after the definition of t. Okay, and now x is not. Now we see that there is just one single line. I don't know if you can see, but there is slightly bluer line somewhere around here, but it's matching so well that you see just one single line. So let we can give them legends also. So this is computed, and this one is true. PLT dot legends, not legends, legend. Okay, so they are matching so well that you see only one of it. Maybe if you zoom in, then you will see some differences, but they are more or less same, which goes to show that these methods are working really well. Okay, so I'll upload this notebook, and you can try to do the same thing with these two problems. Plot the solution and see how close they are. With RK4 also, you will see that they match very well because it's a fourth order scheme. So the error will be delta t to the power 5, which is 10 to the power minus 10. So very small. Okay. So with that, we end. Any questions? Questions, comments, anything? Okay, if not, then let's meet next week.
So,
Yeah,
excuse me. We need to discuss one question from the assignment 6, last week question, assignment
yeah.
6. Question number 2, I got the wrong answer when I tried the code, which is given in your this Google Colab, and
Okay.
I got the answer a little bit different. Like this is a fourth option, which is a 2.243, and then I got the answer 3.243. So it is not matches with anywhere. So I selected near about that. It is a 3.357. So it get wrong.
Are you
Same
talking
for
about
me also.
this one?
One.
Oh, you mean the
No,
uh,
it's from the assignment actually.
this year's assignment?
No, last week. It's a six
Last week,
assignment.
but this year's assignment, right?
Yes, yes.
Uh, the
The second
second one.
question.
Actually,
Yes.
I think it was a typo error. It should be 3 point. Last option.
Yeah, let me open the same.
Assignments.
Assignment.
Yeah,
The
Question
question
number
number
2.
two. Yeah.
question number two.
So I got the answer 3 point
Zero, three,
two
two, four, three.
two four three.
Yeah.
So it is not in the answer. So I selected near about. So I get the wrong one.
Same with
So,
me also.
yeah, yeah. Okay, so you selected this one, right?
Yes, yes,
So yeah, they probably meant this to be 3.243.
yes, sir.
Yeah, but you got it
Yeah.
incorrect. Okay, I'll
So,
inform them.
mhm.
Okay,
And so one more that the one more question.
yeah,
Yeah, if you wish to explain, then it's better. One more,
okay,
I get the wrong. Question number 7 in there. I try hard, but still it get wrong. I didn't. This I find out and then manually calculated that both the e values forward and backward, and I check it that. So it's
okay,
get also wrong one. So can you solve it?
okay. Let's do that. So let me read the question because I haven't. So there is voltage and the equation is given. I think this equation was solved using one of the Eulers in the assignment. So let's say the result from forward is E forward and from backward it is E backward. Round them to two decimal places and then calculate the quantity and then round this. So did you round this E backward and E forward first?
Yes.
Okay, then let's do it. Just a minute, I'll take a photo of this. Let me run all. Where is that thing? Yeah, this one, right? So the equation is same. I of t is equal to 2. This is 0. P is 240. R is this. L is this. Delta t is. And this was Euler forward. Okay, so this value should be forward one, which is 11.99. So it is 12.0. Did you get this one for forward? So E forward is 12.0. Now let's calculate it for the backwards. I think we already had the function for Euler backwards set. Yeah, 2 point backwards f x and h. Oh no, that was just for the derivative. Yeah, this was the Euler backward, right? So x would be replaced by this. Okay, but it's not a linear equation. So you have to theoretically calculate, right? Xn plus 1. Did you do it?
I actually got the wrong answer for both of them. Actually, I got 4.76 for the forward and 4.75 for the backward. Is there a connection between forward and that backward for the with the time scale that delta t become equal to 0.01? So the difference should be in same where or
Difference
back.
should be very close to zero. Yeah, because delta t is if very small, then both schemes should give approximately same answers.
Yes, so that's the reason. So I trust with that answer. I tried the code, but it got wrong. Like your answer is 12, and I got 4.76 over there.
Okay, then that is not correct. So you have to look at forward, but let's do the backward also.
So
So
forward, it is 12. Round figure I have
it
to take.
yeah, so it is 11.996. So if you round, it becomes 12. Okay. Now for backward, you have to first calculate by hand. What should be the next step? Did you do it?
No, I tried with the only that Google Colab, but it get wrong answer. I got the 4.75.
So here is the thing. When the method is not explicit, you have to first find xn plus 1 explicitly, right? Using pen and paper.
Yeah,
So
I
if you,
tried it, but I
yeah,
didn't get where I
okay,
find out.
okay, let's try it then. Let me open the notebook again. Okay, so the our equation is dx by dt plus some alpha x is equal to beta with alpha is equal to 2 by 5 and beta is equal to 24 by 5. Is this correct? You can verify. Meanwhile, let's now calculate. So dx by dt is minus alpha x plus beta. Now we write xn plus 1 is equal to xn plus delta t times f of xn plus 1 tn plus 1, right? This is Euler backward, and which is implicit. So we have to express this in terms of xn minus 1, xn plus 1. So it is alpha xn plus 1 plus beta. So now xn plus 1, the coefficient of xn plus 1 will be 1, and from the right hand side we get plus alpha, not x, sorry, delta t, right? And this is xn plus beta delta t. So xn plus 1 is equal to xn plus beta delta t divided by 1 plus alpha delta t. Okay, I might make some algebraic mistake, so please point out if I do. So, okay, and quick sanity check would be if delta t is equal to 0, then xn plus 1 becomes xn, right? So now let's put this in the formula. So I'll copy paste this thing. And here x will be replaced by 1 plus, no, it was x plus something beta delta t, so I would just say b times dt divided by 1 plus a times dt. Okay, and I have to define what is a and b. So a would be minus r by l, and b would be v by l. Is this correct? The way we have defined? Yeah, a is r by l and b is b by l. No minus. And then append and everything should be same. Let's plot it. Okay, surprising.
A should be, it should contain the minus sign.
A should
Contain the minus sign. Minus R by L should be there, right?
really, because it is dx by dt plus ax is equal to b. That's how I defined it.
Okay, okay.
Yeah, let me just, yeah, dx by dt plus ax is equal to b. With delta t 0.01. So it gives the same answer. So if we round off and then do the difference, then it does not work. So we
So
can do,
I got different answers for E forward and E backward. I
yeah,
got E forward. I got E forward as 6.62
yeah,
and E backward as 6.60.
okay. And
Then I
so
got the correct answer in that option.
it's 6. It cannot be 6, right?
Six, six, six. The correct answer was 15 point something.
And you got it.
Yeah, I got it.
Did you use t is equal to 2 or 1?
One second, sir. T is equal to T final is 2.
Oh, this is 20. My bad.
Uh,
Uh,
R
yeah,
is
yeah, yeah.
20.
Yeah, now I understand. So I remember. So last time when we did, we used to. Then at the end, I showed off by making it 20, so it approaches this value of 12, which is just ratio of V by R, right? So the current flows only through resistor, etc. Okay, so now let's run it with 2, and it is 6.62.
Yeah.
Yeah, let's note it down. EF is 6.62, and the EB again 2.
EB
Yeah,
6.6.
6.6, correct.
Yeah. Then it is correct.
Then it is correct. Let's just calculate for the sake of completeness. So EF minus EB divided by EF plus EB times 10 to the power 5.
4, I think. Then to the power
4,
4.
yes. So EF minus EB divided by EF plus EB times 1E4. You can write like this, right? 15.12 or 13 rather. Is it one of the options? Yeah, 15.12.
Yes. Yes. So initially for the forward, what we are calculated, you got the answer 11.99. That is also wrong one because
That
of
is
that.
wrong. Yeah, because final time I put it as 20 instead of 2. Okay,
Yeah.
this is a variable, and there was a reason why I made it 20. I wanted to see long-term behavior with saturate side. And the I understand the point of question. When you do forward, you generally overestimate. When you go backward, you underestimate. Okay, so there is some error. Okay, so I can upload this one also if you want to. Want me to? Should I?
Please do it today only because tomorrow is a deadline for the assignment. So for the week 7, that
Yeah.
also, if it's possible to do it today, then it will help us more.
Okay, I'll do it today only.
Okay.
Yeah,
Thank you. Thank you
yeah,
very much.
no problem. Yeah. Oh, Rajesh copy pasted the question. Thank you, Rajesh. Uh, do you want me to solve this? No, you have solved it. Oh, okay. Awesome. Any more questions, comments? Guftagoo? Chalo, if not, then it's almost time. Let's meet next week. Okay. Bye bye.